Hi friends, welcome back in this series of FMT. So this is sixth lecture of this series, and I hope you are enjoying the lecture. Now we have another case study in feature extraction and model tuning, which is on heart disease, right? So here the context is a retrospective sample of males in a heart disease high risk region of the Western Cape, South Africa. There are roughly 2 controls per second of CSD, right? So many of the CSD positive men have undergone blood pressure reduction treatment and other programs to reduce their risk factor after their CSD event. In same cases, the measurement were made after these treatment. So these data are taken from large data set described in this South Africa medical journal, right? So what is the problem statement here? Basically, we have this problem statement for the given attribute of patients classify if the patient is suffering from heart disease or not, right? So we have to do it. So we are following the FMT, and we will see how all the topics of FMT can be work on this. So basically, as I said in the beginning, feature engineering is nothing but is the process of using domain knowledge of the data to create features that makes machine learning algorithm to work, right? So let's start with importing necessary libraries. All these we have seen, like matplotlib, inline to plotting graphs, the Jupyter notebook itself, warning to ignore all the warnings, right, by filtering with ignore, numpy, pandas, matplotlib, seaborn, right. Now we have train test split, or we can say the sklearn library that we will use and k neighbors classifier, logistic regression, random forest classifier, gradient boosting, all that all these we have seen in the previous lectures, right. Now sklearn dot matrix import roc auc curve, right. So let's importing with the data. So here we'll be providing this data file into description. You can get the link and get this file, right. So we are separating, or we can see the delimiter we are using as comma, header is 13, names. So all these are the column name that we have into our data. If we frame this into the CSV, so you can see that this is the data that we have. Now let's do a brief exploration of the data. So if we do df.info, right, so we have all the information regarding the data set. So here we have, there are no null values in the data. One of the features of one of the feature is object type, which we will have to console, and this we need to encode here, right. So here df.csd.value counts, if we do this, so we have 0 300 two zeros value and 161 values. Now the data is quite imbalanced, but would not consider it as highly imbalanced. So we will anyway upsample the minority classes. So here we will do df.famist, right, to replace absent with present, right. So 0 1 we are specifying the particular cells, or we can say the indexes, and the in place is true. So here we will do manually encoding the strings, right. Now sns.pairplot to plotting the pairs, right. df we are passing diagonal kind is kde, u is equal to csd. So if we do the plot.show, so here we have all these plottings, right, of the pair plot. Okay. Now here according to this observation, age seems to be good predictor of CSD. So if we check for age, so age is this, and this is with CSD. So here we have the CSD. Where is it? Age. So with the age CSD we can see the 0 and 1. So with the age, it is a good predictor, right. So there is some amount of correlation between obesity and adiposity. Now what we'll do is we will take the x and y here. So for x we will do df dot drop. So we are taking all the column expect CSD and obesity, and the y will contain df dot this CSD. So here, before deciding to drop obesity, we have gone through a couple of iteration of model building, and dropping opacity resulted in better predictions, right? So this has been done by our team as well. Now x train, x test, y train, y test. So train test split we will do for x and y. Stratify we are taking as y, and random state is again y, right? Now x train dot shape, x test dot shape, y train dot shape. If we print all these shapes we can get these like this. Now extra sample, so we are getting some extra in it. Now df of csd if equals to 1, right? Then drop column opacity dot sample. It should take sample of all these opacity as 60 and random state we are passing as 1, right? Now xtrain pd dot concatenate, we are doing it concatenate of xtrain with extra sample from here, and we are dropping, that means we are taking all the column except the CST from the extra sample. Similarly we are doing for y train pd dot concat x train, and extra sample we are dropping now these two CSD and cat, right? The whole column. Now the call before the one above is sample upsampling, where we are duplicating the record. So in the subsequent cell we have tried to use smooth to upsample, right? The former gave us better result in this case. So now let's train and evaluate model. So first we try with the logistic regression. So log reg, we are taking logistic regression in it. Now we are trying to fit our x train and y train. So if we get this logistic regression, so all these values are defined, right, after fitting the model. So if we get the LR score, right, or the score of this model, so we are getting nearly 73% the accuracy score. Now prediction equals to log reg dot predict x test, right? TN, FV, FNTP, all these are we are taking as matrix dot confusion matrix, y test and prediction, right? So here what we are doing is LR recall equals to round TP divided by TP plus FN of 3, right? So what it will do, it will take all the people with CSD and then will return how many were recognized to have CSD, right? Similarly this is for precision. So that means of all the people predicted to have CSD and how many did have the CSD. This is for specificity. So that means of all the people without CSD and how many were recognized to not have CSD, right? So type 1 error we are taking as FP. Okay, so people without CSD predicted to have CSD, and type 2 error, that means people with CSD predicted to have no CSD. Now if we again print all these values, so we are getting LR recall, LR precision, LR specificity, type 1 error and type 2 error, like this. So this is basically to make you familiar with all the concept, like how we use all the FMT or all these terms with our code, right? So props we are using as logreg dot predict probability of x test. So what it will do, it will keep the probability for all the positive columns only. Now we calculate the AUC curve, right? So here we are printing the AUC up to 3 decimal, and similarly we do the ROC curve, right? Then what we do is we are making plot with no skill, right, and plot the ROC curve for the model and show the plot. So here AUC is 0.77, we can say 77%. Now if we do the same with the decision tree, so dt equals to, again we take decision tree classifier, again doing the same thing, fit the model, then we print the score, and then TNFV FNTP, so with the confusion matrix. So we get the accuracy this time at 73, and hope you remember here we got the same as 73, right? Now where is it, this one. So similarly we do the recall precision specificity with this, and you can say this time we also get the same thing. We are using all these algorithm just to make you sure that how different they give the outcome. You can run the notebook by your end and you can see the difference between the algorithm that we have been using, right? So this is for decision tree. Similarly we have done for random forest, right? So again, similarly take this random forest like this, estimator 100, max depth, and random state is 1. And we fit the model, this time we got this 76 with this, right? Again, similarly we print all these similar thing and the AUC ROC curve. So here you can all the compare with all the above. Now we do the ADA boost. So again, for ADA boost we take this as in this classifier, right? And we do the same score to AC dot score, passing X test, Y test, and with the confusion matrix on all these variable. And here we get the score. So the confusion matrix values we take from here, and we just do the same for to print recall, precision, specificity, and all these, and this will print finally value for us, right? And similarly we do for AUC ROC curve, and this time 774, that we get the values. Now gradient boost. So again, similarly take the gradient boost into this variable and fitting the score. After fitting the model we get the score here. So 77.5 we can say, or 77%, right? Now we get the all the confusion matrix values here, and finally we print the AUC ROC curve. So all these above you can do by your end and compare all these values like this AUC and the above algo AUC, similarly the score and the last algorithm score, right? Score, right? Now a result, if we talk about the final result, so here we have the result of all these matrix, NP array, LR recall, LR precision, LR specificity. So all these we get with the inner matrix, then we print the result, right? So result we are containing from data frame model. So all these model as we have just applied, we got the accuracy for all, recall, precision, matrix, right? And if we finally print the matrix here or the result here, so you can see if we apply the model as logistic regression, we got the accuracy, we got the recall, we got the precision, we got the specificity. If we get the, if we talk about the best model we can say so far, so this is this gradient boost, right? In our case, which is giving the accuracy of 77%. Here if we talk about the recall, if it is 70%, and precision is also 66%, and specificity is also 81%. Now what worked in our case to dropping obesity, we have also seen that there was a good amount of correlation between adiposity and obesity. Oversampling, if we check that class imbalanced was an essential part since our target column was highly imbalanced and we could not let the algorithm be biased against the minority classes. So this was all about this heart disease case study with applied of all these five models, and you can see the difference clearly here, how the different model or the different ML algorithm can give us the different and best result. So yeah friend, thanks for being with us. We will come back with a new video very soon.